Welcome to the correlation coefficient. So the idea here is we want a more precise measure of how strong a correlation is. Oops. So we want a more precise measure of how strong a correlation is. And so we introduce the correlation coefficient R. So some things to keep in mind for the correlation coefficient. The correlation coefficient will always fall between -1 and 1. And for the direction, this essentially follows the same pattern as slope. So it may have been a long time since you've studied algebra, but recall a positive slope we go up, the negative slope the graph goes down. The exact same thing applies for the correlation coefficient. So the same applies to the correlation coefficient. So if R is negative, then we have a negative correlation. In terms of the scatter plot, our dots will go down. If R is positive, then we have a positive correlation. So the dots go up. R also tells us the strength, the main reason we want to have this correlation coefficient. The closer to 0 the correlation coefficient is, the weaker the correlation. So the closer R is to 0, the weaker the correlation. And the farther from 0, so in other words, close to -1 or 1, the stronger the correlation. So when it comes to strength of the correlation, it doesn't matter if R is positive or negative. It just matters how close it is to 0 or to -1 or 1. So a weak correlation the pattern is not so obvious. So if we put our band in the background that sort of traces the pattern, it's a very wide band. In this case, R is going to be very close to 0. So R is close to 0. And my definition of weak, I usually say it's between -5 and -0.5 and +0.5. So if we ignore the positive or negative, so ignoring the positive or negative, just looking at the digits, the number, so ignoring the positive or negative, R is less than 0.5 is usually my cutoff for weak. Then we might say something is moderate. The correlation is moderate, so we have a much clearer pattern. My band is narrower here. The pattern is more obvious. For a moderate correlation, again, ignoring the positive or negative, R is between, we'll go with 0.5 and 0.7. This is not precise by any means. This is just the cutoffs that I use. And then for strong, our band is even narrower. And again, ignoring the positive or negative. R is between 0.7 and 1. So if we had a whole series of correlation coefficients and we wanted to order them from weak to strong. So for an example, let's order the following correlation coefficients. From weak to strong. So let's say that we have negative 0.8, positive 0.37, a positive 0.62, a negative 0.45, positive 0.84, and a negative 0.93. So when we order these, we go essentially from smallest to largest if we forget about the positives or negatives. Just a reminder, when we're comparing decimals, make sure they all have the same number of digits past the decimal. So most of these numbers have 2 digits after the decimal. The only one that does not is the first one. We can always add zeros to the end as much as we like. So it's sort of like 0.80. Now, when we compare these, compare them just as if they were 80, 37, 62, 45, 84, and 93. So if we put the weak at the first and strong at the end, we look for the one that is closest to 0. So that would be our 0.37 is the closest to 0. After that, the next one would be our 0.45 but negative, so negative 0.45. Next up, we would go to 0.62, then negative 0.80, positive 0.84, and I didn't leave myself enough room. Last would be negative 0.93. So again, the positive and negative just tells us whether the graph goes up or the graph goes down. The main thing here is that we just want the digits to be in order from smallest to largest. So if I were to classify these, 0.37 and negative 0.45 would both fall in my weak category. 0.62 is on its own in the moderate. And then those last 3 all fall under strong. So this is just some basic how we read the correlation coefficient. In our next videos, we'll look at specific examples in context and how we can interpret it both in terms of strength and direction, as well as what that means for the relationship between the variables.